In these places, 10 minutes is already too late. Our world, so often perceived as a cradle for life, holds pockets of extreme hostility, where the delicate machinery of the human body is overwhelmed in mere moments. We begin with a global perspective, a map of our planet dotted with these unforgiving red zones, before isolating each one for a closer look. Each section will detail the specific environmental threat, be it extreme heat, insufficient oxygen, toxic gases, immense pressure, intense radiation, and chronicle the body's systematic shutdown when confronted with a challenge it cannot overcome. The timeline is unforgiving. We will observe the body's initial response, its desperate and ultimately futile attempts to maintain homeostasis. In the first minute, the body's automated survival mechanisms engage. By the 5-minute mark, these systems begin to falter. As we approach the 10-minute threshold, we witness the cascade of failures leading to collapse and the cessation of vital functions. Throughout this analysis, the language will remain clean and factual, the tone calm and steady. This is an account of limits, a quiet cataloging of the specific points where the human body simply ceases to function. The journey begins in the blistering heat of a North American desert. It then ascends to the oxygen-starved heights of the Himalayas, descends into the theoretical peril of a dense gas cloud, plunges into the crushing pressure of the deep ocean, and finally steps into the invisible storm of a radiological hotspot. Name: Death Valley Basin, Badwater Basin. Coordinates: 36.2419 degrees north, 116.8258 degrees west. City, state, country: Death Valley National Park, California, United States of America. Subtitle: Estimated survival time: under 10 minutes. We begin our survey in the stark, sun-scorched landscape of Death Valley. Here, in Badwater Basin, the lowest point in North America, the environment wages war with heat. During the peak of summer, surface temperatures can soar, creating an atmosphere that acts like a convection oven. The air is intensely hot and profoundly dry, a combination that aggressively draws moisture from any available source. For an unprotected human body, this environment presents an immediate and overwhelming thermoregulatory challenge. The body's primary defense against overheating is evaporative cooling through sweat. But in this extreme aridity and heat, the rate of water loss becomes unsustainable almost instantly. The battle to maintain a stable core temperature is lost before it truly begins. In the first minute of exposure, the body's emergency cooling protocols activate with maximum intensity. The hypothalamus, the brain's internal thermostat, detects the rapid rise in skin and blood temperature. It triggers profuse sweating and initiates widespread vasodilation, rerouting a significant volume of blood from the core to the capillary beds just beneath the skin. This turns the skin into a radiator. The heart is forced to beat faster and harder, placing an immediate strain on the cardiovascular system. By the 5-minute mark, dehydration thickens the blood, making it much harder for the strained heart to pump. Blood pressure drops. The brain begins to suffer reduced circulation. Rising core temperature starts to denature critical enzymes. Approaching 10 minutes, core temperature exceeds 104 degrees Fahrenheit. Sweat may cease, nerves misfire, muscles fail, consciousness wavers. The brain succumbs first. Name: Death Zone, Mount Everest High Camp. Coordinates: 27.9881 degrees north, 86.9250 degrees east. Solukhumbu District, Nepal. Estimated survival time: under 10 minutes, without supplemental oxygen during heavy exertion. Our next location lifts us to over 8,000 meters above sea level, into the region ominously known as the Death Zone on Mount Everest. Here, the challenge is not heat, but its opposite: a profound lack of breathable air. The atmospheric pressure is less than a third of that at sea level. While oxygen percentage is about 21%, low pressure means each breath delivers far fewer oxygen molecules. Within the first minute of sudden oxygen deprivation, chemoreceptors detect the drop and signal the brainstem. Breathing rate and depth increase, heart rate spikes. The system circulates oxygen-poor blood more rapidly to protect the brain and heart. This hyperventilation is inefficient and exhausting in thin, cold air. After 5 minutes, acute hypoxia dismantles higher function. Thinking slows. Judgment fails. Fine motor tasks break down. Vision may blur or tunnel. Coordination and balance deteriorate rapidly. The individual may not recognize their condition. Approaching 10 minutes without intervention, consciousness is lost. The heart can develop life-threatening arrhythmias and fail. Low oxygen pressure can cause fluid to leak into the alveoli. High-altitude pulmonary edema, a drowning from within. Primary system to fail. The central nervous system. Primary system to fail. The cardiac system, both halted by the absence of oxygen. Name: Lake Nyos gas pocket. Theoretical similar site. Coordinates: 6.4600 degree N, 10-1880 degree in E. Northwest region, Cameroon. Estimated survival time: under 10 minutes. Dense carbon dioxide cloud. We now travel to a location where the danger is not in what is absent from the air, but what is present in overwhelming quantities. Volcanic lakes, like Lake Nyos, can become saturated with dissolved carbon dioxide. A disturbance can trigger a limnic eruption, releasing a massive, invisible cloud. Because carbon dioxide is denser than air, it flows downhill, hugging the ground and silently displacing breathable oxygen. An unprotected person would have no visual or olfactory warning. In the first minute, the air might feel heavy, breathing slightly more labored, tingling, mild shortness of breath, often too mild to trigger alarm. The lungs are mechanically functioning, but the inhaled gas is not the nitrogen-oxygen mix the body requires. Oxygen exchange in the alveoli stops. By 5 minutes, severe oxygen deprivation, headache, dizziness, disorientation, rapid loss of strength. Sitting or lying down keeps the victim in the densest layer. As 10 minutes near, blood oxygen saturation falls below levels compatible with consciousness. Collapse follows. The brain suffers irreversible damage and ceases to function. The heart follows, erratic beats, then silence. The lungs continue to move, but they draw in a blanket of inert gas. The first and most definitive failure is that of the brain. Section 5. The crushing depths. Failure by pressure and drowning. Name: deep submerged hull. Coordinates: 0.000 degree N, 0.000 degree E. City, state, country. Open ocean, varies. Estimated survival time: under 10 minutes, from rapid pressure loss or asphyxia. Life is sustained within a bubble of 1 atmosphere. The danger is a sudden hull breach. In an instant, immense pressure and frigid water flood the space. Immediate risks: fatal trauma, violent pressure change, drowning, hypothermia. Compressed air can rupture lungs and other air-filled cavities. At 5 minutes, survivable only with specialized escape gear. Mammalian dive reflex slows heart, but without air, it only delays failure. By 10 minutes, inhaled water fills lungs. Gas exchange stops. CNS has already shut down. Here, the lungs and circulation fail first, leading swiftly to brain shutdown. Section 6. The invisible assault of Fukushima. Failure by radiation. Name: Fukushima. Exclusion: immediate hotspot. Brief exposure. Coordinates: 37.4211 degrees N, 141.0328 degrees E. City, state, country, Fukushima Prefecture, Japan. Subtitle: estimated survival time: under 10 minutes, in highest radiation pockets, acute exposure. In the immediate vicinity of a severe nuclear accident, hotspots can deliver a lethal dose in minutes. High-energy particles and rays bombard the body, shattering DNA, ionizing water, creating free radicals that destroy membranes and proteins. There is no heat, no sound, no sensation. After 5 minutes at extreme dose, neurological syndrome of acute radiation sickness, disorientation, ataxia, seizures. By 10 minutes, the dose is far beyond survival thresholds. The brain ceases higher function. Death often follows within hours or a day. Bone marrow failure collapses immunity and oxygen-carrying capacity. GI lining sloughs, causing fluid loss and infection. In extreme hotspots, the nervous system fails first. Section 7. A symphony of systemic collapse. The human body is a marvel of homeostasis, an intricate network of systems working in concert. Stability depends on a narrow and fragile set of external conditions. Each hostile environment acts as a specific key, unlocking a rapid pathway to systemic failure. The 9-minute timeline represents a threshold beyond which life-sustaining systems cascade into collapse. In blistering heat, circulatory strain, thickening blood, overheating brain. In thin air, lungs, and heart work, but oxygen is absent. CNS and cardiac systems falter. CO2 pockets replace air. Deep breaches crush or flood lungs. Both rapidly drop blood oxygen, leading to brain death. Radiation attacks at the cellular level, shredding DNA and machinery. In extremes, the nervous system is first to fail. Section 8. The Patient Peril. We have journeyed to the edges of the habitable world, to points on the map where the laws of nature are absolute and the margin for human survival shrinks to nothing. Desert basin, mountain peak, gas-filled valley, the crushing deep, irradiated zone. These places are not monsters. They do not possess intent or malice. They operate according to the detached and unwavering principles of thermodynamics, atmospheric physics, fluid dynamics, nuclear decay. They are environments where the conditions to sustain complex life are absent. The human body is an engine that requires a specific fuel and operating environment. It needs oxygen within a narrow pressure range, a core temperature held within a few degrees, an atmosphere free of displacement gases, protection from crushing pressures, and from energies that tear its cells apart. When these conditions are violated, the engine fails. The 9-minute mark is a clinical boundary. It marks when the body's most critical systems begin to shut down without immediate intervention. Brain, heart, lungs. This exploration has been a quiet accounting, a methodical observation of cause and effect. We have built civilizations, explored our planet, and even reached for the stars, yet we remain bound by the requirements of our physiology. These hostile zones are the final arbiters of our physical limitations.